E4 service architecture in Eclipse. The E4 programming model starts with an existing principles of programming in Eclipse. Applications are made up of modular, loosely coupled components called plugins or bundles. Bundles can be made up of code written in Java and other languages or other resources such as documentation and source code. Bundles can declare points where they can be customized or extend using extension points and customize extension or extend other bundles by defining extensions. Very large number of bundles can be installed at a time, but only those bundles that are actually in use will be loaded and consume system resources. E4 differs from the traditional Eclipse programming model is in how bundles interact with each other outside extension registry mechanism. Bundles often need to provide data and software services to other bundles in the ways that aren't suited to Eclipse extension registry. This is most commonly achieved by bundles reaching out to other bundles by directly referencing methods and constants defined in the API Java classes. Bundles would typically define entry points for obtaining singleton instances of services, for example, classes such as platform, ID, resource plugin, Java core, etc. This practice of reaching out led to tight coupling from bundles using services to a particular provider. Of that service, and the prevalence of singleton access made it difficult or impossible for alternative service implementations to be substituted or for multiple implementations to be available at the same time. The resulting bundles were therefore difficult to reconfigure or reuse in different environments where different or multiple service implementation would be needed. The service programming models generally define the three distinct principles: service providers, service consumers, and a broker or container that manages binding service providers to consumers. Normal model, this arrow is in the other side. Basic implementation of this programming model, such as OSGI service API or Eclipse extension registry, nicely decouple service providers from consumers, but often require service providers and consumers to have explicit knowledge of particular container or service broker. The E4 programming model aims to further decoupling these participants by reducing or eliminating these explicit links from the service producers and consumers to a specific service broker technology. This new flexibility is the best explained by looking at how these three service participants are defined in E4. Context: the service broker. E4 introduces the notion of context as a generic mechanism that stores or knows how to locate services and provide them to the service consumers. At its basic level, an E4 context looks much like a Java map storing values associated with some key. A client can put values into the map or retrieve values from the map. The map can also store context functions that are pieces of code that know how to compute the context value lazily when values are requested by the client. When a client asks for a value not currently defined in the context, it will delegate to a parent context. This allows services or data to be stored in a central place and consumed by many clients. Finally, contexts have a pluggable lookup strategy that allows external parties to reach and context how to retrieve certain kind of values. Lookup strategy enables interoperability between E4 context and other service brokers such as OSGI service registry. This flexibility means all manner of different service lookup and brokerage systems can be integrated into the E4 context mechanism. This ability to create context hierarchies and insert service lookup strategies allow context to scale up from very simple map like service registration and lookup to highly complex and dynamic service abstraction, service arbitration mechanisms. Injection service consumers. The best practice in modern service programming models is that consumers receive dependencies via dependency injection. This theoretically allows application code to completely eliminate its dependency on a particular container technology, thus enabling greater reuse. E4 directly supports and encourages dependency injection as a means to supply services to clients. Constructor, method, and field injections are all supported. The injection points can be identified in client code, either naming conventions or Java annotations. For clients that find inversion of control confusing and prefer code clarity over framework dependencies in framework independence, for the E4 context API can also be used directly. The service locator design pattern. Service providers. There is a great variety in services and data that bundles make available for consumption of by other bundles. Some services are very lightweight and may be consumed and discarded thousands of times, while others are heavyweight services designed to live for long period of time. There are many different life cycles to these services. Some come and go based on the existence of a particular UI widget. Others may be tied to a life cycle of a bundle. Due to this great variety, there is no single method of service publication that is appropriate for all service providers. In general, services are published in E4 using OSGI service mechanism. Services can either be registered and removed programmatically or via OSGI declarative services. Declarative services allow the service instantiation to be delayed until required by some client. Of course, there are a wide variety of helper framework that can be used for publishing OSGI services, such as SpringDM, iPocho, Peerberry, etc. By using OSGI services as the foundation for service publication, all of these frameworks can be used seamlessly in E4. While most client code will use services, frameworks that create context can simply add services directly to a context where appropriate. For example, a service associated with the widget may want to register with the context with the widget constructor and withdraw the service when the widget is disposed. Manual registration allows the service to be made available only to a specific context rather than making it globally available via OSGI services. Finally, context supports outjection, reverse injection of services back into the context via a field or accessor method. Putting this all together, we have a model where a typical service consumer knows nothing but who provided the service, about what broker is used to bind and obtain service. The service producer can also be largely decoupled from the service broker by separating the service configuration data from the service implementation itself, either using declarative mechanisms such as DS outjection or simply by separating the framework aware code doing registration from the service implementation itself. This model is illustrated in this figure. and Eclipse application services, the 20 things. To support this decoupled service programming model, Eclipse API need to be made available as services rather than via the singleton accessor model in the past, platform, workbench, etc. However, over the years, Eclipse platform has accumulated a vast API, of which many components use only a few. This API breadth alone make Eclipse a challenging platform to build applications on. The steep learning curve increases time to value and discourage casual developers from building on platform. This is being addressed in E4 by defining a core set of services that capture a broad swath of platform functionality. The goal is that many developers should be able to build well integrated E4 bundles using only these core services. These core services are occasionally referred to in E4 discussions as 20 things to capture the fact that it is bounded the set of important services. The core services also define good starting point for integration of the Eclipse platform with other programming languages. Here you can see a service broker context. Service broker context is connected to here service declaration through service introspection or outjection. Service declaration is connected to producer here. Here service broker context is connected to consumer through service injection. Now this is the end of my presentation. Thank you very much for watching it.